Okay, so today we're working on properties of exponents. This is a part 1. So we are going to be working through this on a couple of days here. All right. So product of powers is our very first property. This is for any real number a and integers m and n. A to the m power times a to the n power equals a to the m plus n. Okay. You all already know how to do this. Let's think about it. Because what is x times x? You know that's x squared, right? And if I said, well, what's x squared times x squared? You all would tell me, oh, hey, that's x to the 4th. Okay, so in this case, each case, we've just added the exponents together. 2 plus 2 gave us 4. We got an ninja 1 here and a ninja 1 here. 1 plus 1 equals 2. So that's all we're doing. So let's look at our first example here. X to the 4th times x to the 9th. Well, what is 4 plus 9? That's 13. So this is just x to the 13th power. Same way here, y squared times y to the 5th. Remember, when it doesn't show an exponent, it's a ninja 1. So 2 plus 1 is 3, plus 5 is 8. So this is y to the 8th power. And we can quickly get through the rest of the examples. All right, I've got a w and w here. Only like terms combine, so I'm not concerned one bit about this y to the 6th. He's just going to go down and not be changed at all. So w to the 4th, w to the 10th, so w to the 4 plus 10 gives me w to the 14th. All right, same way here. All right, we're multiplying. So don't forget that when you're multiplying, numbers get multiplied by numbers, letters get multiplied by letters. So first, what is 4 times negative 2? Is negative 8. A to the 4th times a to the 3rd. Remember, we add exponents. So a to the 4 plus 3 is a to the 7th. B to the 7th times b to the 5th gives us 7 plus 5, which is 7, 8, 9, 10, 11, 12. So b to the 12th. And there's no c here to multiply with this c, so it just gets brought down. All right, same thing here. Combine like terms. All right, negative 4 plus 6 gives me 2. Plus 7 gives me 9. So this is b to the 9th. All right, pretty simple so far. All right, the quotient of powers or dividing powers property says that a to the m over a to the n is a to the m minus n. All right, so the key idea is in a fraction, subtract the exponents. Big minus little, all right, gives you big. All right, so what this is saying is whether your big number is on the top or the bottom, that's where your answer is going to be. So let's look at this for a second. So y to the 7th over y to the 3rd power. So we're going to say 7 minus 3. Big minus little gives me y to the 4th. The big one was on top, so that's going to stay on the top of my fraction. All right, and this is y to the 4th over 1. We can just say y to the 4th. All right, so now let's look. This one. We're dividing. Remember, number rules still work. So I'm saying 4 divided by 2 is 2. And again, that's on the top. X to the 22nd power minus x to the 5th. So 22 minus 5 gives me what? 17. So x to the 17th power, the big one was on the top, so this stays on the top. This all got divided down to 1. So my answer is 2x to the 17th over 1, or just 2x to the 17th. Now, what about in this case? You notice that I've got my big one on the bottom. So I'm still going to say big minus little. So 12 minus 5 is what? 7. So y to the 7th power. But my big was on the bottom of the fraction. So I keep my answer on the bottom of the fraction. So this answer becomes 1 over y to the 7th. And oh boy, look at this. Okay, this seems complicated, but let's take it one piece at a time. All right, 18 divided by 3 is 6. The big one was on top of the fraction, so it's going to stay on top of the fraction. All right, w to the negative 12th, w to the 20th. Which one's bigger? Obviously, w to the 20th. What is 20 minus negative 12? Right, 20 minus negative 12. Well, we don't subtract a negative. We add a positive. So 20 plus 12 is 32. and our bigger one was on the bottom, so we're going to move this to the bottom. So w to the 32nd power. Look next to the x's. X to the 8th, x squared. Big minus little, so 8 minus 2 is 6. The big one was on top, so we stay on top. Next, look at the y's. Y to the 12th, y to the 3rd. 12 is bigger, so 12 minus 3 is 9. The bigger one was on the bottom, so we stay on the bottom. So my answer here is 6x to the 6th over w to the 32nd power, y to 9th. All right, looking at our next example. Do the same thing. Numbers first. 16 divided by 2 is 8. Biggest one was on the top, so we're keeping it on the top. M. I have no m's at all, so it just stays on the top where it was. N to the negative 5th over n to the negative 5th. What happens anytime I have the same number over itself? It goes to 1. So I could write 1 here, but anything times 1 is itself, so we're just going to leave. So my answer is 8m to the 4th over 1, or we can just say 8m to the 4th. And this is a 4, not a 9. All right, power to a power. The key idea here is when the exponents are together, you're going to multiply. All right, so looking at this, a to the m power to the n power means a to the m times n. All right, looking at our first example, x to the 7th power to the 5th power. We're going to multiply these two exponents together. So x to the 7th to the 5th. So 7 times 5 is 35. So this answer is x to the 35th power. All right, same thing here. 2 times 4 is 8. So it's z to the 8th power. Oh no, we have 3. Okay, doesn't change your rules. Same concept. So 5 times 4 is 20. 20 times 7 is 140. So this becomes y to the 140th power. Oh, and look here, our last one, we're going to have a problem within a problem. So first, let's do our multiplication. So a to the 3 times 4 power is a to the 12th times a to the 2 times 5 power is a to the 10th. Oh, and now we're saying a to the 12th times a to the 10th. Remember when we're multiplying, we add our exponents. So a to the 12 plus 10 is a to the 22nd power. All right, let's flip the page over. Let's look at the back side of our notes. The power of a product. All right, the key idea is apply the exponent to everything within parentheses, including the numbers. So this works a lot like the distribution rule. Remember when we're distributing something, we say x times 3 minus y, right? And we distribute that x to everything inside the parentheses. So we'd get 3x minus xy. All right, we're doing the same thing, only on this, we're distributing an exponent. So the exponent on the outside gets distributed to the exponent of everything inside the parentheses, including the numbers. So if I'm looking at this one, our first example here, the 4 gets distributed to the exponent of this one and the exponent of this one. So I have 3 to the 4th power, x to the 4th power. And then we can actually evaluate what 3 to the 4th power is. So 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, and 27 times 3 is 81. So my answer here is actually 81x to the 4th. All right, let's look at the next one. We're going to distribute to the exponents. So this becomes x to the 3rd, y to the 3rd. All right, now we've not looked at one like this yet, but let's take a look. So I have w to the 4th, z to the 5th, all of that to the 3rd power. And I've been saying it, but let's actually look at what happens. We're going to distribute this to the exponents. So when I'm distributing it to the exponents, we're multiplying. So 3 times 4 is 12. So this is w to the 12. 5 times 3 is 15. So z to the 15th power. Because we raised a power to the power, we multiply. All right, same thing here. Distribute the exponent to the exponents of every number in parentheses. So 5 to the third power, y to the 2 times 3 power, which is 6, x to the 5 times 3 power, which is 15. And then we can actually find out, we can evaluate what 5 to the third is. So 5 times 5 is 25, times 5 is 125. So 125, y to the 6, x to the 15th. All right, next, distribute this. All right, so 3 to the third power, x to the 4 times 3 power, so x to the 12th, and 3 to the third power is 27, so 27x to the 12th. All right, something important to remember, please, please, please pay attention. This does not work if the pieces are being added or subtracted inside the parentheses. All right, so their example, x plus y to the third power. I am not allowed to distribute this here. No, 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 that does not work. Another example, if I had 3x plus 2, and I said squared, all right, I can't just distribute this, because what does squared mean? Squared means I'm taking everything inside the parentheses times itself. So if I just distributed the exponent, I'd end up with 3 squared x squared plus 2 squared. All right, but if I actually do what squared means here, I have to take 3x plus 2 times 3x plus 2, because squared means times itself. And then I have to follow the double distribution or FOIL. So first, which is 9x squared outside plus 6x insides plus 6x, and lasts plus 4. So I end up with 9x squared plus 12x plus 4. Does this look like that? No. Okay, so very important to remember, only distribute the exponent on the outside when there's multiplication inside, not for addition or subtraction. All right, last rule, power of a quotient. All right, so this is taking what we just did with multiplication up here, and we're just applying it to division. And it says when you have an exponent, a fraction raised to an exponent, the entire fraction in parentheses raised to an exponent, you just distribute the exponent to every single piece in parentheses, top and bottom of the fraction. So looking at the first example, y over x to the 5th power. We distribute the 5 to the exponent on every number in here. So this becomes y to the 5th over x to the 5th. All right, looking at our next example, distribute the 8 to the exponent of every number in here. So this becomes a to the 8, b to the 8th, over c to the 8th, d to the 8th. All right, next example, we've got some numbers that already have exponents on them, but that's not a big deal. Remember, when we raise a power to a power, we multiply. So let's distribute the exponent to the exponent. So 2 to the 3rd power, x to the 9th power, y to the 3rd power, over y to the 15th power. All right, so we've done all of our multiplication, but now we need to simplify some things. So first thing we need to do, 2 to the 3rd power is what? So 2 times 2 is 4, times 2 is 8. I have only one x, so it stays put. But look, I've got two y's. I've got y to the 15th and y to the 3rd. So remember our quotient rule that says you take big minus little, and then you put it on the top or bottom wherever big is. So 15 minus 3 is 12, and the bigger one was on the bottom, so it's going to stay on the bottom. So y to the 12th. So that is our answer for this one. All right, let's do the last one. So distribute the exponent to the exponent. So 2 squared x to the 8th over 3 squared x to the 6th y. All right, so let's do our multiplication here. 2 squared is 4. 3 squared is 9. Oh, look, I have two x's. X to the 8th, x to the 6th. Big minus little gives us 2. 8 minus 6 is 2. Big was on the top, So we're going to say x squared. There's only one y, so he stays where he is. Can I reduce this any further? Nope. So this is my answer, 4x squared over 9y. And that is all we have for today. Be sure to email me if you have any questions or send me a message through Canvas. I hope you all have a great day.